Today we're going to be going over soft curl perms and chemical relaxers. And I want to explain to you first what both of those mean, because soft curl perm is usually a little frightening to people. They don't know exactly what you're talking about with soft curl perm. A soft curl perm is used on someone who has extremely curly hair that's unmanageable, but they don't want all of the curl relaxed out of it so that they have to style it all the time. So what we do is use a product called a rearranger, and what it does is it breaks the disulfide bonds in the hair. And it's usually thioe, which is the same product we just used on our mannequins. And it relaxes that curl out, but it leaves the hair in kind of a straightened form. So once we've used the rearranger on it, we're going to come back and roll it on rods and put thioe on it again to make it take the shape of the perm rods. And naturally we're using bigger rods because before it was just tight, kinky curls. Now we want it in some curls that once we get through with the processing and neutralization, we can just put a little oil sheen on it or conditioner on it, and they can just let it dry and wear it just like it come off the rods. Some of y'all been looking at your perms this morning as you process them and see how pretty they are just in that natural form. And that's what a soft curl perm is. A chemical relaxer, on the other hand, is a product that is meant to put on the hair and take all of the curl out of curly hair. And once all of the curl is out, then that hair can be worn straight. It can be rolled on rollers for a temporary shampoo and set. Styles can be changed often. So the first thing we want to talk about is the structure of the hair, because in order to understand how these products are going to work, we've got to understand how the hair is itself. And we've been over this some, but we want to go over it again. The cuticle is the outside protective covering of the hair. It's often referred to as imbrications or cuticle scales. It has no color. You can see through it. It doesn't have any of the bonds that's in hair. And the purpose of it is protection. So any chemical we put on the hair has got to penetrate through that outer cuticle layer in order to get to the cortex, where our bonds are and where our coloring matter is. And when we go into hair coloring, we're going to be studying this same structure of hair again. Got to open the cuticle scales to get into the color. At this point, we've got to open the cuticle scales to get into the cortex. Cortex is the middle layer of the hair. It's directly beneath the cuticle layer. The polypeptide chains of the cortex are connected by end bonds and then cross-linked by side bonds that form fibers and structure of hair. These chemical bonds hold the hair in its natural wave pattern. They are responsible for the incredible strength and elasticity of human hair. Breaking the side bonds of the cortex makes it possible to change the natural wave pattern of the hair. Now let's talk about our bonds. This is not new information to us because we've been through these bonds before. We have only one end bond, and that's called peptide. Peptide bonds are end bonds. They're also chemical bonds. That means they're connected end on end on end. This goes back to when we talked about how hair grows and it goes through the zone of keratinization. This goes back to what we eat. When we eat or we eat protein substances, we chew it up and it's digested, and the amino acids are derived from it and go right into our bloodstream. Our bloodstream in turn feeds the hair as it grows through the hair bulb. And the amino acids again begin to connect to each other, end on end, by means of peptide bonds. There are so many of these peptide bonds and amino acids in the hair that we have change. You remember how the hair was intertwined with each other? That's why it's called polypeptide chains. We never want to break peptide bonds because we have no means of reforming them. Even though they're called chemical bonds and chemicals can break them, we cannot reform them. So we want to be real careful about that. The way we break them with chemicals is by putting a chemical on hair. The chemical's too strong and the hair will not tolerate it. or putting a chemical on there and wandering off somewhere and leaving it for too long of a period of time. Then we have our side bonds. Now remember that peptide bonds are our only end bonds. We have a lot of different side bonds. We talked about hydrogen bonds, that when we take the hair to the sink and wet it, those hydrogen bonds are broken. We have more hydrogen bonds than any other type of bonds in the hair, but they're weak. We talked about having your hair fixed and then you walk out in the rain, you got an umbrella, but just the mist and the moisture in the hair will break the hydrogen bonds. They're side bonds, but they're physical bonds, so they can be broken and reformed by physical means. The next side bond that we're concerned with, and this plays a big part in permanent waving, chemical relaxing, and soft curl perms, and that's our disulfide bonds. Disulfide bonds are formed between two cysteine amino acids that are located on neighboring polypeptide chains. Remember our twists again. You know, we got the polypeptide chain here and here and here and here, and all of it's wound up in the fibers of the hair. A disulfide bond joins a cysteine sulfur atom on one polypeptide chain with a second cysteine sulfur atom on a neighboring polypeptide chain, and this is how they form cysteine. Cysteine is simply the oxidized form of cysteine. Disulfide bonds are weaker than our peptide bonds, but they're much stronger than hydrogen or salt bonds. Disulfide bonds are chemical bonds. All right? Our peptide bonds are chemical, but they're end. Our hydrogen bonds are physical, but they're side bonds. And our disulfide bonds now are side bonds that are chemical. Although they are fewer disulfide bonds than hydrogen or salt bonds, disulfide bonds are the strongest of the three side bonds and account for about 1/3 of the hair's overall strength. The chemical and physical changes in disulfide bonds make permanent waving, soft curl perms, or curl reforming, and chemical hair relaxing possible. And as we go through all this, we're going to discuss more and more how we break them and how we reform them. The next type of side bond is the salt bond. They're relatively weak physical side bonds that are the result of an attraction between opposite electrical charges. Salt bonds are easily broken by changes in pH, such as in permanent waving. They reform themselves when the pH returns to normal. Even though salt bonds are far weaker than disulfide bonds, the hair has so many salt bonds that they account for about 1/3 of the hair's total strength. Do you remember when we was talking about shampooing the hair that sometime our shampoos were alkaline? Those shampoos broke our salt bonds. And what did we decide when we use alkaline shampoos on the hair? That we need to follow up with a conditioner that's acid? Yes, because we want to close the cuticle scales back up, but we also want to reform our salt bonds. And remember, salt bonds again are physical. A wet set is an example of a physical change that results from breaking and reforming the hydrogen bonds in the hair. Wetting the hair breaks the hydrogen bonds and allows the hair to be stretched and wrapped around rollers. Drying the hair removes the water and reforms the hydrogen bonds. These changes are temporary. As soon as the hair is wet or exposed to high humidity, it goes right back to its original shape. Thermal styling with hair dryers, curling irons, and pressing combs also breaks hydrogen bonds. These styles involve a physical change with temporary results. So if the client doesn't like it, it's easy for them to go back. But we are now working in chemicals, and it's not so easy. One of the first things we want to do is hold a client consultation. We want to make sure they fill out a medical form. We want to find out what types of medication they're on, what types of medical problems they may have, because everything that affects the body affects the hair. We also want to make sure we fill out a permanent wave record or a soft curl perm record or a relaxer record, and that's to tell us what was this hair like when we started, what did we use on it, what was it like when we got through. And this is of vital importance to us when this client comes back to us. I loved the relaxer you put in my hair last time. It did the best, and it didn't seem to damage my hair. And our intentions are good about remembering this, but are we going to remember it since we've done 40 more relaxers since she was there? We're not. We need to know exactly what we done. We need to know how long we left it on there. What product did we use? What maybe extra steps did we take with her hair because we knew it was fragile? So take the time to go through your client consultation. During that consultation, you also want to do your analysis, and that's of the scalp and hair. And I always call the scalp analysis the first step, because if we do the hair analysis and find everything's in order, and then we get to the scalp analysis and then there's abrasions or scratches or diseases or disorders, we can't go any further. So save yourself time. Do your scalp analysis first. Why can we not proceed with a service if we find abrasions or scratches or diseases? Why can we not put a chemical on this client? It what? Could make them sick? Why? Because it's open. Where might our chemicals go then if it's open? On into her system. That's right. Least case scenario, it could cause infection or burning of the open place. So I want to be real careful about our scalp analysis. The next thing we want to do is hair analysis. And the reason we're careful about doing hair analysis is we've got to choose the product we're going to use. We've got to choose the strength of the product we're going to use. We've got to determine how long do we need to leave it on. So we need to know a lot of things about the hair. The first thing we're going to consider is the texture. What is texture? What do we mean by hair texture? Coarse, medium, or fine. And the products for these things are run the spectrum. Coarse hair usually requires more processing than medium or fine hair. It may also be resistant to processing. It's usually more difficult for permanent waving solutions to penetrate coarse hair. So that tells us we're going to need a stronger chemical. We may also need to leave it on longer, hadn't we? Medium hair is the most common hair texture. It's considered normal. It doesn't pose any special problems for us. And that's about 75% of the clients we see in the salon are going to be medium texture hair. Fine hair is more fragile. It's easier to process. It's also more susceptible to damage from our chemicals. As a general rule, fine hair will process faster and more easily than medium or coarse hair. So can we use a strong chemical on it and go ahead and get through? No, because if we do, we might burn the hair or melt it. We want to use a milder chemical, and we want to watch it closely because it may not take very long. Hair density is the number of hairs per square inch on the head, telling us how thick or thin the hair is. Individuals with the same hair texture may have different densities. Some individuals with fine hair texture, characterized by each hair having a small diameter, may have high density with many individual hairs per square inch. Others with coarse hair texture, which is characterized by each hair having a large diameter, may have low density or may not have very many hairs per square inch. The next thing we want to consider is porosity. Porosity is the ability of the hair to absorb moisture of any kind. The reason we're discussing it here is the faster our hair absorbs our chemicals, the faster it's going to begin work, isn't it? Yes, it gets in there quickly. The porosity of our hair changes by how open or how closed our cuticle scales are. That's what causes porosity. Resistant hair has a tight, compact cuticle layer that resists penetration. Chemical services performed on resistant hair require a more alkaline solution. High pH is needed to raise the cuticle scales and permit our saturation and processing. Resistant hair also requires a slow and thorough application of perm solution. If we just zip in the bottle over it, then it's not having time to open those cuticle scales. We've got to take our time as we bring the bottle across and make sure that solution has time to penetrate. Hair with normal porosity is neither resistant nor overly porous. Texture services performed on this type of hair will usually process as expected, and that goes back to our medium hair. It's about 75% of our clients. Porous hair, or hair with high porosity, has a raised cuticle layer that absorbs the solution quickly. Chemical services are performed on overly porous hair requires less alkaline solutions. A lower pH minimizes the swelling and helps prevent excessive damage to the hair. Remember, we've already got a lot of swelling there if the hair is porous because the cuticle scales are open. Hair elasticity. We have to consider hair elasticity a lot more in chemical relaxing than we did in permanent waves because of the way we put a chemical relaxer on. Even though some of our chemical relaxers may be made out of the same basic ingredients, there is a thick cream added to the relaxer because the product itself has to hold the hair into the form that we want the hair to turn into. It's like hand cream that's in jars. That's about the consistency of it. But we don't roll this on rods. We're going to comb it down straight. And remember, it's naturally curly, and naturally curly wants to pop up into the curls. So as we put the product on, we depend on the product holding the hair into the new form that we're hoping to chemically achieve. So elasticity is vitally important. Hair elasticity is an indication of the strength of the side bonds that hold the individual hair fibers in place. More than any other single factor, the elasticity of the hair determines the ability to hold curl. Hair elasticity is usually classified as normal or low. And that's where our rules come in, and we've already heard these rules before because of stretching the hair. This is the rule that gets most hairdressers in trouble with their hair cutting clients. The client comes in, we shampoo or at least wet their hair. We comb it down and we cut it, forgetting that wet hair will stretch 50% of its length or 1/2 of its length and then return to normal. Dry hair will only stretch 20% or 1/5 of its length and return to normal. So this wet hair stretch gets us in trouble. It can get us in trouble here too if we're not careful. If we keep combing the relaxer product through, we're just stretching and stretching and stretching. And now we have the cuticle scales wide open with the relaxer on there. We also need to consider the direction of hair growth. The individual growth direction of the hair causes hair streams, whirls, and cowlicks that influence finished hairstyles. One of the main reasons we want to consider these is the wrapping pattern, because we do not like to wrap against the natural hair growth pattern. What happens if we roll against natural hair growth? Breakage. It breaks. Or it at least makes it weak where it may break later on, so we want to be careful about that. Now we want to discuss our chemical hair relaxers and what they are. And basically they're the same thing as permanent waves we've just went through, but with one major difference, and that's the reforming of bonds when we talk about sodium hydroxide. Chemical hair relaxing is the process of rearranging the basic structure of extremely curly hair into a straight form. Whereas permanent waving curls straight hair, chemical hair relaxing straightens curly hair. Other than their objectives being so different, the two services are very similar. In fact, the chemistry of thiol relaxers and permanent waving is exactly the same. And even though the chemistry of hydroxide relaxers and permanent waving may be different, all relaxers and all permanents change the shape of the hair by breaking the disulfide bonds. The two most common types of chemical hair relaxers are thiol and hydroxide. Extremely curly hair exists in all races. That means anyone of any race or mixed race can have extremely curly hair. It's also true that within races, individuals can have hair with different degrees of curliness. Extremely curly hair grows in long twisted spirals or coils. Cross sections are highly elliptical and vary in shape and thickness along their length. What they're talking about with cross sections is we take one hair. This is really splitting hairs, let me tell you. And instructors fuss about this all the time. Take one hair and slice it down its length and then open it for view. And you can tell where the length or the diameter of the hair be like this, then it'll go like that, all along the length. Curly hair is worse at that than straight hair is, having different diameters all along the shaft. Compared to straight or wavy hair, which tends to possess a fairly regular and uniform diameter along a single strand, extremely curly hair is irregular, exhibiting varying diameters along the single strand. The problem with this is when we start combing the relaxer and all in, is where the thinnest places or where the tightest coils are is where the hair has a tendency to break. And if we put this product on there and start combing and all this and pulling on it, then we're going to break it as its weakest point. And the rule of thumb to always remember is a chain is only as strong as its weakest link. And we know we've got some weak links in there, even though we might be analyze this hair to be good hair. We've got to remember in extremely curly hair we've got weak links through there. Relaxers are characterized by an extremely high alkalinity and can literally melt or dissolve hair if used incorrectly. Most relaxers contain the same ingredients used in depilatories. But depilatories are a product used for temporary hair removal, and the way they temporarily move that hair is they dissolve it. If you've ever used knead or nair or anything on your legs or under your arms, you were using sodium hydroxide. Hydroxide relaxers are not compatible with thiol relaxers because they use a different chemistry. Now what this means to us is the person that comes into us that's been getting a hydroxide relaxer and decides she wants a soft curl perm cannot do it. Soft curl perms are thiol. The person that comes to us that has had a soft curl perm and decides she wants to relax cannot do it. You cannot put sodium hydroxide where thiol has been, or thiol where sodium hydroxide has been.
And that's until the new hair grows out?
That's until new hair grows out. You never put it on that hair that has been...
Hair. Okay.
Right. You can on the new hair, but not the other. All hydroxide relaxers are very strong alkalis that can swell the hair up to twice its normal diameter and are not compatible with thiol relaxers. Thiol relaxers have a pH of about 10 and use thiol to break the disulfide bonds. Although the high pH of a thiol relaxer swells the hair, thiol breaks the disulfide bonds. Hydroxide relaxers have an even higher pH. The average pH of the hair is 5.0 and many hydroxide relaxers have a pH over 13. Remember we said from 11 to 14 was kind of unusable chemicals on the pH scale. Y'all remember that, from 0 to 3 and from 11 to 14? So we're stepping outside the safe area now. Since each step in the pH scale represents a tenfold change in concentration, a pH of 13 is 100 million times more alkaline than the pH of 5. And remember, the hair falls in the 5 range. Hydroxide relaxers break disulfide bonds differently than in the reduction reaction of thiol relaxers. Hydroxide relaxers remove one atom of sulfur from a disulfide bond and then converts it into a lanthanide bond by a process called lanthanization. Disulfide bonds contain 2 sulfur atoms. Lanthanide bonds contain only 1 sulfur atom. The disulfide bonds that are broken by hydroxide relaxers are broken permanently. Therefore, they can never be reformed. And that's one of the main reasons you can't go back now and use thiol on that hair. Unlike thiol neutralization, the neutralization of hydroxide relaxers does not involve oxidation. The deactivation or neutralization of hydroxide relaxers neutralizes the alkaline residues that are left in the hair by the relaxer. The pH of hydroxide relaxers is so high that the hair remains at an extremely high pH level, even after we've rinsed. Remember, our water is what, 7? So 7's got to bring it down some. Although rinsing is important, rinsing alone does not deactivate the relaxer or restore the normal acidic pH of the hair and scalp. We know that acids neutralize alkalis. Therefore, the application of an acid-balanced shampoo or a normalizing lotion neutralizes any remaining hydroxide atoms and helps lower the pH of the hair and scalp. Some neutralizing shampoos intended for use after hydroxide relaxers have a built-in pH indicator that changes color to indicate when the pH of the hair has returned to normal. Let me tell you what that means. We've got some neutralizing shampoos, and after we feel like we've rinsed all the relaxer from the hair, we apply some of this shampoo. It may go on pink. If it runs into any relaxer that's left in the hair, then it will indicate by color change that there's relaxer left. It will usually turn blue. So if that happens, we want to shampoo good with it, rinse it, and apply some more shampoo that will stay the color. There's also a company that come out with one called 2 cents, and not 2 cents like 2 pennies, but 2 cents, S-C-E-N-T-S. We put it on, and if it run into relaxer in the hair that we had left in there from rinsing, it gives off a disagreeable smell. If it didn't come into contact with any relaxer in the hair, then it gives off a real pleasant flowery smell. You know, we like the smell of it. So it's good to use something like that to indicate to us, has the relaxer all been removed? Since the disulfide bonds that have been broken by hydroxide relaxers cannot be reformed by oxidation, if we take a neutralizer that contains an oxidizing agent and put it on there, it's still not going to rebuild those disulfide bonds and may actually damage the hair because of the oxidation. Now, it is important that we use a neutralizing type shampoo because although we can't reform the disulfide bonds, we can close the cuticle scales down. We can also take the hair back to closer to its normal pH. We have some other types of hydroxide relaxers. Metal hydroxide relaxers are ionic compounds formed by a metal such as sodium, potassium, or lithium, which is combined then with oxygen and hydrogen. Metal hydroxide relaxers include sodium hydroxide, potassium hydroxide, and lithium hydroxide. Although calcium hydroxide is sometimes added to hydroxide relaxers, it's not used by itself to relax hair. All metal hydroxide relaxers contain only one component, and you're used straight from their container. We don't mix them with anything. A lot of our relaxers we do mix. The hydroxide ion is the active ingredient in all hydroxide relaxers. There is no significant difference in the performance of these metal hydroxide relaxers. Sodium hydroxide relaxers are commonly called lye relaxers. We want to keep this lye and no lye separate now. Sodium hydroxide is the oldest and still the most commonly used relaxer. Sodium hydroxide is also known as lye or caustic soda. Sodium hydroxide is the same chemical that is used in drain cleaners and chemical hair depilatories. Lithium hydroxide and potassium hydroxide relaxers are often advertised and sold as no mix, no lye relaxers. Although technically they are not lye, their chemistry is identical and there is very little difference in their performance. We have a caution here and we want to talk about it for a minute too. Application of a thiol relaxer or thiol permanent on hair that has been treated with a hydroxide relaxer will not properly relax or curl the hair. It also may cause extreme damage. Hair that has been treated with hydroxide relaxers is unfit for thiol relaxers or our soft curl perms. Our next type of relaxer is guanidine hydroxide relaxers that are usually advertised and sold as no lye relaxers. Although technically they are not lye, the hydroxide ion is still the active ingredient. Guanidine hydroxide relaxers contain two components that must be mixed before we use them. They straighten hair completely with much less scalp irritation than other hydroxide relaxers, Most guanidine hydroxide relaxers are recommended for sensitive scalps and are sold over the counter for home use. Although they reduce scalp irritation, they do not reduce hair damage. They swell the hair slightly more than other hydroxide relaxers and are also more drying, especially if we continue to use them on that client. Our low pH relaxers. Sulfites and bisulfites are sometimes used as a low pH hair relaxer. The most commonly used are ammonium sulfite and ammonium bisulfite. Sulfites are marketed as mild alternative relaxers. Y'all remember about the alternative perms that didn't last a whole long time? They are compatible with thiol relaxers but not compatible with hydroxide relaxers. They do not completely straighten extremely curly hair. Low pH relaxers are intended for use on color-treated, damaged, or fine hair. Then we have our no-base relaxers or base relaxers. What a base is, and we always use a base around the hairline to protect the scalp and ears and nape area or the forehead area. We always put that base no matter what type of perm we have. The smart cosmetologist will also use a base even with a no base relaxer. No base means that it has an additive to protect the scalp, to keep the perm from burning the scalp. But oftentimes the scalp still gets irritated with application.
Want that cream all in here too?
It's wise to put it even when the relaxer says no base, yes. Because when you put that, it's a cream that does not allow the relaxer to penetrate through it. The thing you have to be careful about is any hair that you get it on is not going to process properly either. Hydroxide relaxers are usually sold in base and no base formulas. Base cream is an oily cream used to protect the skin and scalp during hair relaxing. Base relaxers require the application of base cream to the entire scalp prior to the application of the relaxer. No base relaxers do not require application of a protective base. They contain a base cream that is designed to melt at body temperature. Now we're saying this separates from the relaxer and comes down to the scalp to protect it. That's why it does not work as well as applying a base, prior to application. No base relaxers are simply an improvement on the protection that is provided by the oils in all hydroxide relaxers. For added protection, base cream may be applied to the entire hairline and around the ears even with base or with no base relaxers. Alright, our different strengths of relaxers. Most chemical hair relaxers are available in 3 different strengths: mild, regular, and super. The difference in strength of hydroxide relaxers is due to how much hydroxide is contained in the formula. Mild strength relaxers are formulated for fine hair, color-treated hair, or damaged hair. Regular strength relaxers are intended for normal hair texture with a medium natural curl. Super strength relaxers should be used for maximum straightening on coarse hair that is extremely curly. Our caution is to make sure that the client has not had hair coloring containing metallic salts such as gradual or progressive hair colors before applying either the thio or the hydroxide relaxers. Extreme damage could occur. What is our procedure for chemical relaxing? We know that we're not going to roll it on the rods. So through our consultation and analysis, we got to find out what type of hair she has. Now we're going to assume that we're doing a virgin application, meaning it has never been processed before. The best thing we can do is take a strand test to see if we've chosen the correct strength, how long it needs to stay on there, how the hair relaxes, did it take out enough curl, did it take out too much curl. And then if our strand test shows it's all right, we go on with our application. Now we're going to do a practical application, but I'm going to just briefly tell you how we do it, and then we'll do a demo on it. We're going to part the hair into 4 sections, right straight down the middle, right straight behind the ears. And they're going to be section 1, 2, 3, 4. We start in section 1. We come out 1/2 to 1 inch away from the scalp and begin to apply our product. And we pull the product on the hair strand until we reach porous ends, meaning where the cuticle scales are standing more open than they were on the middle. We do the whole head. That's step 1. We do the whole head that way. We come back to our starting point and we put the product to the hair closest to the scalp that we had left, the 1/2 to 1 inch away from the scalp. We do the whole head in step 2. Then we come back and pull it through the ends. Now the reason we don't put it on the whole strand is hair closest to the scalp will process faster because of body heat. Hair at the ends, or the porous ends, are going to accept the product more readily because the cuticle scales are open. So that's why we have step 1, 2, and 3. We also want to make sure we include in our steps of chemical relaxers, we're going to relax, going to neutralize or use a neutralizing shampoo, and then we want to use a conditioner. A conditioner is always part of the process. We also want to do periodic strand testing while our product is on there. We were talking then about sodium hydroxide application. The application step for theo or thiol relaxers are the same as those, although the neutralization procedure is different. Remember, if we use a thiol product, we've got an actual neutralizer, not a neutralizing shampoo. So when we use thiol, we want to make sure all of our product's out of the hair, and we put that neutralizing solution all over the hair. We can then follow it with a neutralizing shampoo, and we certainly want to follow it with a conditioner to help close the cuticle scales back down. And to answer a question you haven't asked yet, but most times students have this, which is the most popular type of relaxer, the thiol or the sodium hydroxide? Sodium hydroxide is the most commonly used. About 85 to 95% of the relaxers you'll do will be sodium hydroxide. Relaxer may be applied with bowl and brush, an applicator bottle. Can only be applied with an applicator bottle if it's a thiol, because the consistency of the sodium hydroxide would not allow that, or the back of a rat tail comb. Although all thiol relaxers follow the same procedure, different application methods are used for virgin relaxers and retouch relaxers. So what is the application procedure for a retouch? Whenever the client comes back to us in about 6 to 8 weeks, we're going to only do the new growth of hair. That's all we put the product on. So we don't come out 1/2 to 1 inch away from the scalp. We're going to do the hair right there on the scalp. We don't want to reapply the relaxer on hair that we had previously relaxed. Soft curl perms or curl reforming. Soft curl permanents or curl reforming do not straighten the hair. They simply make the existing curl larger and looser. And I don't like that statement. I wish they'd just leave that part out, do not straighten the hair. Because the fact of the matter is we use a rearranger that does take the curl out of the hair or straighten it before we roll it on the rods. A soft curl perm may also be called a jerry curl or simply a curl. A lot of people will call and say, I'd like to make an appointment for a curl. Some people will call and say, I'd like to make an appointment for a curly kit. It is a combination of a thiol relaxer and a thiol permanent that is wrapped on large rod. Soft curl perms use ATG and also oxidation neutralizers, just as thiol permanent waves do. A soft curl permanent is actually 2 services. Extremely curly hair must be relaxed with a thiol relaxer or curl rearranger before it's wrapped on tools. All base sections should be horizontal with the same length and width as the perm tool. The base direction should be in the direction of hair growth. The base control should be half off base. We know how to do all that already, don't we? Horizontal placement, off base, getting our subsections the same size of our tools. Once it is wrapped on large tools, it is then processed with a second thiol solution called the curl booster. We use the rearranger. Now we're going to use the booster on the curls. After processing, the hair is rinsed, blotted, and neutralized, just as we've done with our permanent waves. Some safety precautions. Perform a thorough hair analysis and client consultation before the service. Examine the scalp for abrasions. Do not proceed with the service if redness, swelling, or skin lesions are present. Keep accurate and detailed client records of the services performed and the results. Have the client sign a release statement that indicates that the client understands the possible risks involved in the service. When I first started teaching, there wasn't a salon in town that had a release form, but now all your smart salons have a release form, and a release form does not relieve you from liability of doing something negligently, putting the solution on and walking out and leaving your client. But it does relieve you of some of the things that may occur anytime you use chemicals, such as burning the scalp. You know, even if you do all you can do, putting the base on there, you will get something like that, breakage of the hair. So you want to always have clients sign a release statement before you do any chemical on them. Every client that comes through this school has to sign a release statement. If they are under 18, their parent or guardian must sign that release statement for them. Do not apply a hydroxide relaxer on hair that has previously been treated with a thiol relaxer. Do not apply a thiol relaxer on hair that has been previously treated with a hydroxide relaxer. Do not chemically relax hair that has been treated with a metallic dye. Do not relax overly damaged hair. Suggest instead a series of reconstruction treatments. Do not shampoo the hair prior to the application of a hydroxide relaxer. Now, if you notice, before we use thiol, we've shampooed. We don't wet the hair or shampoo the hair before hydroxide. The client's hair and scalp must be completely dry and free from perspiration prior to the application of a hydroxide relaxer. Apply a protective base cream to avoid scalp irritation. Wear gloves during the relaxer application. Remember what the pH of relaxer is. What did we say it might be? 13? Protect the client's eyes. I like to keep a bath cloth and fold it up and place it over the client's eyes while I'm rinsing, because that's a good time to spatter it into their eyes. If any solution accidentally gets into the client's eyes, flush the eye immediately with cool water and refer the client to a doctor. Wouldn't you really feel good? You've done your client's hair, and during the process you've got to send her to the doctor for something you did or didn't do. Do not allow chemical relaxers to accidentally come into contact with the client's ears, scalp, or skin. Remember, they burn. It's like a chemical burn. Perform periodic strand tests to see how fast the natural curls are being removed. Avoid scratching the scalp with your comb or fingernails. Do not allow the application of a relaxer retouch to overlap onto that hair that you previously relaxed. Never use a strong relaxer on fine or damaged hair. It may cause breakage, and a lot of hairdressers thought they got really smart. The stronger the chemical they use, the faster the process works, so they want to use the strongest on everybody to get done. They wound up with a lot of clients with a little bit of hair. Not good. Do not attempt to remove more than 80% of the natural curl. To do so breaks so many bonds that the hair becomes weak and may fall out. Thoroughly rinse the chemical relaxer from the hair. Failure to rinse properly can cause excessive skin irritation and hair breakage. Use a normalizing lotion to restore the hair and scalp to their normal acidic pH. Use a neutralizing shampoo with a color indicator to guarantee that the hair and scalp have been restored to their normal acidic pH. Use a conditioner and wide tooth comb to eliminate excessive stretching when we comb out the tangles. Remember, this hair is fragile now. Its bonds have been broken. Do not use hot irons or excessive heat on chemically relaxed hair. Performing texture services involves powerful chemicals, which must be handled with the utmost caution. If you act responsibly and perfect your techniques, your services will be in great demand. And the next thing I'm going to ask you to do through this is I'm going to do a demonstration and show you how to do a chemical relaxer. And I'm going to ask you to use cholesterol and go through and do it time after time. That's to build your speed. Because this is different than your perms. You rolled your perm up and all you had to do is squirt the solution on it. This time, as you are going through the sections and subsections, you are applying a strong chemical, and you've got to learn to move just like that. If you don't, this back here is going to be relaxing for an hour before you get all the way around, and all that hair is going to just fall out on the floor. Do I have questions?